Okay, all right, so now we're going to be talking about simplifying radicals. So before, when we were solving by square root method, we were getting square roots, right? So we were doing things like x squared would equal 16, take the square root of both sides, and x equals positive negative 4. Now, that turned out to be a really nice whole number right there because 16 is called a perfect square. Now, there are going to be situations where we don't have perfect squares and we have to figure out how to deal with those and how to simplify those. So just like if we had 8/10 and I asked you to simplify that and it becomes 4/5, right? We're not changing the value of that. So 8/10 is the same thing as 4/5. 4/5 is just the simplified version of it. So I like to think of it as like a dollar bill and 4/4, right? So it's 4/4 is the same amount as a $1 bill. It just looks different. So we're changing it to use it how we need it, right? Okay, so let's talk about simplifying radicals. We have two different methods, and I'm going to show you both methods, and you are free to use whichever method you like the best. Okay, so we have factor tree method. So if you remember back from middle school, factor trees, right? We have 32. We're finding factors that multiply to give us 32. So I'm going to say 16 and 2. If you said 8 and 4, that works. 2. So then 16 breaks down into 4 times 4, and then we have 2 times 2, and 2 times 2, and then we have that 2. Now, the only numbers that I'm concentrating on or that I'm looking at are the ones at the very end of each branch, right? So we're only looking at this 2, all of these 2's. Okay? Now, if we think of the radical as jail, right? In order to break out of jail, you have to have a partner. If you don't have a partner, you have to stay in jail. Okay? So we have 2 2's here, and we have 2 2's here, right? So these both have partners, and then this 2 is all by itself. So this 2 has to stay underneath the radical, right? Now, we have this 2 and this 2. We have pairs. Now, we don't need the pairs. We just need what number the pairs are. So we have 2 and 2, and we always multiply. So 2 times 2 gives me 4, radical 2. Okay, so again, I had a pair of 2's here and a pair of 2's here, so I multiplied those together, and this went on the outside because we had pairs. All right, let's look at another one. So if we have 12, I'm going to break this down into 4 times 3. So 4 is 2 times 2. So I have a pair here, and then this 3 is all by itself. So the pair comes out, and the one left by itself stays underneath the radical. Okay? All right, let's keep doing. I think the more you see these, the easier that these get. All right, so for square root of 30, so if I have 30, so 5 times 6 and 2 times 3. Right? I don't have any partners. There's no pairs whatsoever. So guess what? Square root of 30 is already simplified. There's nothing more I can do to that. So this would stay as square root of 30. All right, negative 45. So when I do my factor tree here, I like to put 45 times negative 1 because this negative 1 reminds me, remember we said by definition the square root of negative 1 equals I. Right? So this reminds me that I'm going to have to pull out the negative 1 and turn it into an I. So then I break down 45, so 9 times 5 and 3 and 3. Again, you could have done 15 times 3. It doesn't matter. So I have a pair of 3's here, and then this 5 and this negative 1 are by themselves. But remember, negative 1 is that's my special one. I know that has to come out. You can never leave a negative underneath the radical, ever. Okay, so the pair comes out, 3 comes out, 5 stays under, right? And then I have this negative 1, so that actually goes next to the 3. So this right here would be my final answer, okay? Never, ever, ever, ever leave a negative underneath a radical. You can't do that, okay? So for example, if this was negative 30 underneath here, I would just break this down into the square root of 30 times the square root of negative 1, right? So this would be 30 would say like that. The square root of negative 1 is I, so this would be I radical 30. Okay, I know it gets kind of complicated, but it's not too bad. All right, let's do some more examples. So these are some bigger numbers, right? So if I have 150, so if I did 15 times 10, this breaks down into 2 times 5. This breaks down into 3 times 5. So then if I look, All right, I got a 5 here and a 5 here, so I got a pair of 5s, so that comes on the outside. And then 3 and 2 are left over on the inside, so I multiply those together. So I do 3 times 2, and that gives me 6. So 6 is what goes underneath the radical, okay? If you think about this, what number did I have to take the square root of to get 5? Well, that would be 25. And 25 times 6, that gives me 150, right? All right, let's try 810. So I'm going to stick with the easiest way I know how to do it. So 81 times 10. This is 2 and 5. 81 becomes 9 times 9. And those each break down into 3s. So if I notice, I have a pair of 3s and a pair of 3s, right? So 3 times 3 on the outside, and then I'm left with 2 and 5 on the inside. So 2 times 5 on the inside. So this is 9 radical 10. Okay? For 500, right? So I'm going to do 50 times 10. So 2 and 5, 5 and 10, and then 5 and 2. All right, so on this one, I got a pair of 2s, right? So that goes on the outside. I've got a pair of 5s. That also goes on the outside. And then I have this one lonely 5 left over, so that stays on the inside. Okay, again, only pairs come out. So if you have 3 of something, 2 of them come out, but the 1 stays under. So 2 times 5 gives me 10 radical 5. Okay, so that is factor tree method, right? Pretty simple if you remember how to do factor trees. Not too bad. All right, then we have another way. It's called the perfect squares factors. Okay, with this one, instead of making a factor tree, I'm just going to list all of my factors of my number. Okay, so 1 times 32, 2 times 16, and 4 times 8. So then I look at my list, my factors list here, and I find the biggest number that is also a perfect square. Now, remember, our perfect squares means 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, 13 times 13, 14 times 14, and 15 times 15. Those are my perfect squares, right? So we're comparing our two lists, our factors with the perfect squares. So I want to find the biggest number that's in this list that is also over on this list. So I notice I have 4 and 16 are both on this list over here. But I want the biggest number, so it's 16. So I'm going to break this up into the square root of 16 times the square root of 2, because it's 2 times 16. That's the same thing as the square root of 32. Square root of 16 is 4, and then we keep the radical 2 because it's not a perfect square. Okay, so on this method, it requires you to know your perfect squares, and it also requires you to know your factors of your number. Okay, so for example, 12 would be 1 times 12, 2 times 6, and 3 times 4. 4 would be my biggest number that is also over here on the perfect squares. So this is square root of 4 times the square root of 3, so this would be 2 radical 3. And again, we're getting the same answer no matter what method we're doing, right? Here's factor trees method. We're getting the same answers, it's just a different method. Square root of 30, so we have 1 times 30, 2 and 15, 3 and 10, 5 and 6. There is not a number that's on this list that's also on my perfect squares list. So therefore, there's nothing I can do to this, so this stays radical 30. Okay? For negative 45, I automatically go ahead and put down that I have a negative 1 underneath the radical. Then I just deal with 45. Right? I write down all my factors of 45. The biggest number that that is also on my list of perfect squares would be 9. So I have square root of 9 times the square root of negative 1 times the square root of 5. Square root of 9 is 3. By definition, the square root of negative 1 is I. And then this is not a perfect square, so I just leave it under the radical. Okay? Now, once you get to these numbers, this is when the perfect squares, the factors, gets a little bit more difficult because there's lots of factors of 810. There's lots of factors of 500. So I highly recommend using factor trees when you get to numbers this large, right? We tend to forget some factors and different things like that. So factor trees would definitely be the way on this. So that's the only limitation to our perfect squares factor, is that once you get really large numbers, it gets a little bit more difficult, okay? All right, so the other part of this is this worksheet that I want you guys doing. All right, so all you do on this, for example, on this first one, so we have square root of 20, right? So whatever method you want. So I'm going to go with the factor trees. So this is 4 times 5, and then 2 times 2. So here's my pair. So 2 comes out, and I'm left over with 5. So 2 radical 5. So then over here, I'm looking for 2 radical 5, which I see is right here. Obviously, if I don't see my answer, I know I did something wrong, and I need to go back and fix it. So then this box over here tells me how I'm supposed to color the box in the puzzle. So on this one, I'm going to use my red here. So this whole side is colored in, right? And then this triangle right here is colored. Okay, obviously you can color better than me, but as long as it's colored in, you can use a highlighter. I know highlighters are easier to color with. So then you just go through and you do all of these and you find it, and this picture right here is going to be a pattern, right? And then once you're done, you should have filled in or have something on all of them. Now notice like 125 is blank, so that means you're going to leave that one completely blank. Okay, so there will be one that's going to be blank. All right, that's what you guys need to work on. You can do your work on this paper if you have enough room, or you can use a separate sheet of paper. So again, just to go over again, 27. So we have 9 times 3, and then 3 breaks down. So I have a pair of 3, so that comes out, and then I have 1 3 left over, so that stays in. Okay, pretty simple. If you have questions, please make sure that you are asking those to me. Thanks, guys.